You randomly choose a point P on the unit sphere. What is the variance of the z coordinate? Let's first start by illustrating the unit sphere. We'll then populate random points along the surface of the unit sphere. After, we'll compress them along the z-axis. This diagram represents the distribution of the z-coordinates along the z-axis on the interval -1 to 1. Let's start by understanding that variance is the expected squared deviation from the mean. This translates to the mathematical definition, expectation of x minus expectation of x squared. We can apply the mathematical FOIL method to expand this expression. After, apply the linearity of expectation to get 3 distinct terms. And finally, we can combine like expressions to get the reduced expression that we see so commonly describe the variance of random variable x. Let's now compute each term independently. The expectation of the z-coordinate is equal to 0. This is an observation that can be made by observing the unit sphere, more specifically, the symmetry along the z-axis. The symmetry along the z-axis implies an average z-coordinate value of 0. Let's now compute the expectation of z squared. We begin with the equation of the unit sphere, x squared plus y squared plus z squared is equal to 1. We take the expectation of both sides. And by a similar logic to calculating the expectation of z, we observe that each term, expectation of x squared, expectation of y squared, and expectation of z squared, are symmetrical along their respective axes. This means that they're equal, and we can aggregate them as 3 times the expectation of z squared is equal to 1. We then solve for the expectation of z squared and get 1/3. Lastly, we combine these sub-expressions to get our final answer. The variance of z is equal to 1/3. Thank you for watching. If you enjoyed the video, please like, subscribe, and check out our parent site, OpenQuant.co. Of course, if you have an alternative solution, please comment it below. We'll pin the best one. Thank you.